welcome to the lecture. My name is Dash. I'll probably introduce myself in just a little bit. Just a quick bit about ATAR Notes. First of all, welcome to the lecture. Um, Now, since 2007, here at ATAR Notes, we've been offering free resources, just like this video, um, to make sure that students can really not just survive their studies, but actually thrive in them, right? And lectures like this have been offered since 2015. Now, the reason we offer, free lectures and other free resources that I, as a student myself, used all of these, um, is because it's in line with our mission to help students as much as possible. And, that's why there's tons of resources out there, okay? Easily accessible online. I know probably the one that most of you guys have seen is probably the ATAR calc. I loved jumping on there, seeing where I'm tracking, and that actually helped inform my subject decisions. Because I was like, oh no, psychology won't scale as well as like methods or specialists, right? But there's also Q&A, heaps of articles, freely written by, elite grads who've done it all before. They know what they're talking about. Study notes, and also free videos as well. Potentially this is your first interaction with ATAR Notes, so hop on these before those externals because we do know they're coming up. So yeah, if you go to atarnotes.com, you can find heaps and heaps of stuff. Have a bit of a wander around. Um, Besides free resources, one thing I did, this is how I started interacting with ATAR Notes and became a tutor here, was actually ATAR Notes Plus. So there was this really good deal for like 3 months, and I got it like kind of this time of the year last year, and everyone else did as well because we were like, well, where are we going to get our practice exams from? But you know, you do it for the practice exams, but then you get these complete course notebooks, which you can write your summary pages off, and then flashcards, stuff that is so content heavy, like biology. There's also good text guides because I'm not very good at English, but having a text guide that someone's already analyzed it for you kind of just makes you that little bit more informed. Cannot recommend enough. I personally, as a student, got the like 3 monthly, a subscription for 3 months, and I found it immensely useful. I mean, you need volume of topic tests, especially for math, especially for chemistry, and where else do you get it? To be honest. um, yeah, so we've got free notes, videos, free guides from past students. That's all available online. And then if you do want extra support, make sure you sign up to ATAR Notes Plus. Like I said, I do have personal experience with that one. All right. Now, welcome to the methods lecture. Now, this is kind of a probability type wrap up. That's what we're mostly going to focus on. Kind of rounding up Unit 4 because you've been taught all that content now. This should make a fair amount of sense, okay? I will still explain it quite simply, but you want this to kind of be making sense just by the fact that, we've hit holidays now and the external exams aren't that far away. So this is a really nice revision tool where you can kind of go, okay, I know that, I know that. And if you don't know something, maybe you play that part of the video 2 or 3 times. Okay. If there's a formula you need to memorize, I will point it out. I'll do my best to kind of relate my lived experience having sat that external last year, and done well. So this is my proper introduction. My name is Dash. I'm a first year medical student up at JCU, in Cairns. So I graduated last year from Redland State College, with an ATAR 99.15. As you can imagine, you know, to get an ATAR that high, you have to do methods, you have to do specialists. I didn't do physics, so I had like bio as my other one, and chem. And for methods, I got 49 on the internals and 48 on the external exam, which I was super duper happy with. Now, I will note last year's external exam was definitely the hardest. That's not my bias. That's um, like um, I've heard from the teachers all have like this page, and they basically said, "Wow, what the heck? That was so hard." So it was hard, and that's because they're trying to kind of protect the scaling. If you did specialist, you would have found it a fair bit easier because there was a genuine just like specialist question that was in there. but it kind of highlighted to me, like if I was just a methods student, that you kind of need really strong breadth as well as depth. Because yeah, all well and good, you can do that one question really well, but you kind of needed the breadth of knowledge. Like we had a simultaneous equation logs question that popped up last year. To date, I haven't met anyone else who's solved that question. It was really, really hard. Um, and that, I don't even know if I specifically revised it. Okay, rearranging log equations. No. And sometimes that happens. But importantly, you do get part marks, so give it your best shot, and you will do better than you think. Just a little fun fact about me. I love running. Great way to ease the stress. I've run several marathons, and one ultra marathon. It was only 50K, so it's not really like a big one. But um, yeah, I did that to try and prove that I could. All right, let's get into it. How this is basically going to work, we've got a 2 hour lecture. There's going to be two main blocks of content, and we have a bit of randomized revision that I'm going to throw in there. If you've got questions, this isn't live, but I will be sitting in the live chat right now. So please ask away, whatever it is, content, uni, whatever it's about. Maybe sniffing through a question, you're like, oh, how do I do this? Or you're interested in what resources specifically I use for my methods revision. Sure, ask away. I'm in the live chat, so go for it. You can always rewatch the video. And then yeah, so if you see a question that's like yours, make sure to upvote it. And then, well, we've kind of shown you the resources so far. To be honest, it is kind of comprehensive what Aton Notes Plus does. So I wasn't getting anything else besides Aton Notes Plus for my external study. And as we know, methods is all about those practice exams. All right. So we've got three topics. Sorry, I'll just briefly introduce them. First, we're doing kind of the miscellaneous things in Unit 4. Firstly, second derivative three. Some of it, all of it, potentially is revision for you from year 11 and year 10. But if it's not, no problem. We'll go through it properly. Topic 2, kind of probability basics, and then we move on to normal probability. It'll kind of, I know those, it's basically just part 1, part 2 probability. Probability is very broad, and there's several subtopics in each one of those topics. Right, topic 1, the second derivative and trigonometry. So, as we kind of learned at the end of year 11 and revised for you would have had to for your I1, sorry, I2, there's a few different rules we use for differentiation. Firstly, we have the power rule, product rule, quotient, and chain. Now, all three, or all four rather, these are all on your formula book. So don't be worried, don't be frantically writing this down. This is just me recapping. Um, but the real kind of extension to this, which is what is being taught in Unit 4, is the second derivative. So the second derivative is useful for several things because mathematically it has this property where um, it's like acceleration. That's the best example you can think of. So car's moving. Um, how fast is the car moving? Meters per second. Well, that's going to be velocity. But then, is that speed going to go up or down? The acceleration tells us that, right? That means that the acceleration is the second derivative of the displacement vector. Okay. So knowing your differentiation, you've done it to death by this point. But knowing your differentiation is important. Do not neglect it. And when you see it, like you might just get a question. It's like, oh, what's the derivative of this? Don't just rush over it and get onto that hard probability question, which is combining multiple types of probability. Actually, stop and think about it, because too many people, even for specialists, will say, "Oh," and they get these marks, which should be the easy, like lock this in. This is going to help you pass. They miss those marks because they will do like integration. It's such an easy mistake to make. Like you're like, oh, especially if you've been doing lots of integration questions, kind of just looks the same. You go and do it, and you feel so stupid, and you're not stupid. your mind's just working a bit too quickly. So take the time and slow down in the exam. It's okay. You're not going to run out of time. You can get it done in the time. So if we have a function f of x, this is just a bit of notation. If we find the derivative of that function, we usually say f dash x, f apostrophe x. Um, that's the first derivative. The second derivative, f apostrophe apostrophe x. Third derivative, f apostrophe 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 x. You can see that these apostrophes just mean derivative, and so on. We can keep going, but usually we just talk about the first derivative and the second derivative, and the second derivative is is the derivative of the first derivative. So we just have to do differentiation twice. So the second derivative is actually the one. Well, the reason it can be useful is that it tells us more about the shape of the graph than just the first derivative alone. So the first derivative, while great, doesn't really get us the depth. It's the second derivative that we use to kind of tell us a little bit more. You would have talked extensively about this in Unit 3, stationary points, and the nature of a stationary point. I'm sure you're probably pretty sick of them. If not, and you're like, what did he just say? Go back, watch the video for Unit 3, give yourself a bit of a refresher, and it's not too complicated. So you will understand it by looking at it again. Okay. So the first derivative gives us the rate of change. Okay? That is a core principle. First derivative is the rate of change. But then what does the second derivative give us? And it may sound confusing, but it's actually the rate of change of the rate of change, which sounds like a bunch of gibberish, but in essence, it's like, it actually tells us whether the first function is going to go up or it's going to go down. Okay? Whereas if we just had velocity, that's not going to be quite so useful to us. Okay? And velocity or speed would be an example of the first derivative. Yeah, exactly. So the slope of the function is going to, whether the slope is going to become more positive or negative. Here is a nice illustration because having a strong kind of graphical understanding of things is super, super, super duper important, especially for math. So if we look, we've got these stationary points. So this is just the displacement vector, or rather, this is just f of x. Okay, nothing fancy here, no derivatives or anything crazy. This is just a function. Okay, um, could not tell you. Well, we got 1, 2, 3. It could be cubic, because we got 3x intercepts. Maybe. Who knows? I'm pretty sure it's cubic. um, Now, if we look at these two stationary points, although the first derivative is both 0 here, that tells us nothing. That just says that, oh, yeah, it reaches either a min or a max, which isn't actually that useful because it doesn't tell us, like, if we had to draw it based off this, that's not going to tell us whether it's going to go up, down, what's going to happen. So what we would do is then find the second derivative. So the first derivative here at this maximum point here would be 0. But the second derivative would be negative because it's a max point. And essentially, think of the negative as it's about to go down. Like it's hit its maximum point. Second derivative is negative, which means that the graph is actually going to go down after that, down negative. Um, Conversely, if we look at this point here, this is another stationary point. So this would be a minimum. And the first derivative is once again going to be 0. But if we do like a second derivative test, the second derivative here will be positive. Why is it positive? Because it's about to go up after that. So this is kind of just a way you can graphically map it. And QCEE has asked questions in the past where they'll be like, oh, this is, they won't even give you values. They'll just be like, the first derivative is positive here, positive, negative, whatever, something like that. Now draw the graph roughly. And if there's no scale, it doesn't matter where you draw it, you just draw it. Okay? Um, and so you have to have a strong graphical understanding and understand, second derivative negative, it's a maximum. First derivative 0, it's a stationary point. Um, etc., etc. All right. So if the second derivative is greater than zero, i.e. it's positive, guess what? It's concave up. It's going to go up. It's like a little smiley face. Things are going to get better. Um, so we're going to be smiling. Um, Next we have if it's decreasing, that means it's concave down. So it's and there's our minimum. If it's, and this is where we kind of have this little bit of a confusing, it seems to contradict a bit because it's like our minimum is concave up, and you got to remember, you got to think like, okay, we've hit rock bottom and it's now going to get better. Should we be smiling? Of course we should be. It's going to get better. And likewise, um, if we're at our peak, probably not going to be pretty happy. If we know we've peaked, that means we're going to go down. Okay? It's like the stock market, and you see it, it's at a peak, and you should have sold all the way back here, but then it starts falling. You're like, oh no, you would be not smiling, that's for sure. So having that strong graphical understanding is really important. Concave up, smiley face; concave down, frowny face. Now we have this other kind of scenario, which is when it's the second derivative is exactly zero. Now, if the second derivative is exactly zero, we're saying likely it's point of inflection. Now, I think I've done one question where it wasn't a point of inflection. It was super duper weird. I think it would be very mean for them to ask that when this is the topic where they want students who are potentially going to struggle to pass to be able to conceptualize this. Great, pass based off that, okay? Because they want everyone to pass. So I really would find it unlikely that we have the weird, obscure case. They're probably gonna test like a probability question over something like this, or optimization is probably a better thing to test. So yeah, it's likely a POI, point of inflection, which tells us that the shape itself is about to change. And then it's kind of point of inflections are more weird. You cover them extensively in Unit 3, kind of where it goes from concave up to concave down. And if you think about it, it's like, well, if you were to graph the second derivative's negative, there's this brief instant, hits zero, and then it goes positive. That brief instant where it's zero is this inflective point. It's where we're actually changing over, okay? All right. What are some applications? Why is this important? Going back to what I said before, position, velocity, and acceleration. Position vectors are also known as displacement, velocity also known as speed. So if the position of something in a straight line is given by xt, so x being displacement, t that's the like independent, no, not independent variable, yeah. It's what we would usually think as the x, so like y equals mx plus b or whatever. That x is now a t, so they use a little bit weird notation. But if we find the derivative of xt, that's going to be velocity. Then if we find the second derivative of xt by differentiating vt, we're going to have acceleration. Okay? And this is what we were talking about before, right? Now, I will note just something that popped up in my head. I did stuff this up the first time I did it. Um, if we are doing a displacement vector, if the value is negative, it's going to go to the left. If it's positive, it's going to go to the right. Now, the reason I say that, because you're like, yeah, duh, of course, it's physically left and right on the graph. You actually lose a mark if you don't say whether it's gone left or right, because the question, how far has it gone? Where has it gone? And you're like, oh, it's gone 15 meters. Easy, no worries. I'm jumping on to the next question. You just lost half a mark for absolutely nothing. So make sure you say left and right. So in your little therefore statement there, and you say therefore, it's gone 15 meters left or 15 meters right. Okay, super super duper important. I do not want you losing marks for stuff that you damn well know. All right. So understanding this relationship means if you know one of these functions, you can unpack a lot of useful information about a system. What does that mean? you know the velocity vector or the velocity equation, you're going to be able to find the displacement or the acceleration. All right, here's an example question. So the position x of a particle after t seconds is given by the function xt equals 4 minus cos pi t divided by 4 between 0 and 8 minutes. Question A, find the function for the acceleration of the particle. Then B, find the times at which the particle is not moving. C, find the times at which the particle is not accelerating. Classic question, simple, familiar. Sorry, not anything too difficult here. Now, pause the video, take 5 minutes. Because this is kind of in revision, right? These are just extra practice questions for you. Have a go. If you can't get it, that's fine. I'm going to kind of step through it. I can't write it out physically, but I'll kind of explain to the answer. There will be an answer on this next page. So pause the video. All right. So firstly, we've got that function. To find the function for the acceleration is the second derivative of the displacement vector or the displacement equation. So what we're going to do is that we're going to use our differentiation rules to find first the velocity, and then we're going to turn that into an acceleration vector. So 3 lines are working here. First, what's the go? Well, this 4, they're using power rule here, and they're using like the full working out. You don't need to write 4 times t to the power of 0. That's kind of like we get that. Yeah, we don't need to know that. And you just know that if it doesn't have a t in it, we don't care. We just get rid of that entirely. Then we have minus 4 cos pi t on 4. Now, you know that the derivative of cos is sine, and then you just pull the 1 over a, you just pull the a value out to the front. That is a chain rule by pattern. Now, you do need to know the by pattern rules, because yes, potentially you could be doing, chain rule in an exam, but it takes way too long. I do not recommend you do that. I had friends who did that. It was not very clever. Um, but also with integration, you're not going to be able to. There's no chain rule for integration that you get taught in methods. So you're actually going to have to. You're going to have learned those by pattern rules. Okay. That's just a little tangent, not an actual tangent, but you're gonna have to look at those and make sure you memorize them. If you've done the correct quantity of questions that you should, you will know them off by heart just because you've used them that many times. But for now, don't worry if you're still looking them up because you will pick it up across time. Okay. Now we know cos goes to sine. Is there a little negative in there? Well, I couldn't tell you because all you do is you just go to the data booklet. The data booklet's there for a reason. Um, the formula sheet. Please, please, please don't neglect it. It's right there. They're gonna give it to you. Click open. Oh, it's positive sine or negative actually. So we pull the a value out to the front. The a value is this thing times t, so pi on 4. Now, if we pull pi on 4 out the front, the 4's cancel and it just becomes pi, like over here. There's also a negative, so when we switch from cos to sine due to the derivative, there's a little negative that cancels out that negative that was already there. So we're left with this pi sine pi t on 4. Note the thing in the brackets, just that stays for it. Like we could do a bazillion derivatives, that's going to stay the same. Then we do the whole thing again, and that's to find the acceleration, which is the second derivative. So we just take the derivative of the first derivative, pull out the a value again, a value pi on 4. Then we get this pi squared divided by 4. Then we find the derivative of sine, which is positive cos. Awesome. And as you can see, nice cancelling. B, find the times at which the particle is not moving. So if the particle is moving, it has speed, it has velocity, it's moving. But if it's not, that means the speed is going to be 0. So it's not moving at all. So what we're going to do actually is just sub in velocity, speed equals 0. We solve for that. Now this is a potentially tech-free question. It'd be a bit rough, but it is. It's potentially tech-free. You could use a calculator, of course, but um, if we put 0 here, if we strike off that pi, we get 0 because we just divide 0 by pi, and all of a sudden we got 0 equals sine pi on 4t. Now, because we're talking about sine, what we do is we make 0 into, oh, when does sine equal 0? At 0, at 2 pi, at, well, at 0, at pi, at 2 pi, at 3 pi, 4 pi, 5 pi, etc., etc. So we got sine 0 or 2 pi or 3 pi, etc., etc., equals sine pi on 4t. Then what you can do is you can strike off the signs so that we're left with um, basically pi on 4t equals either 0, pi, 2 pi, 3 pi, 4 pi, etc. Okay? Then what we do is we have pi on 4t equals pi, 2 pi, etc., etc. We then multiply out the 4, divide out the pi, and then we're left with t equals 0, 4, 8, etc., etc. Okay? You could probably also work it out by like going, okay, what's the period, and kind of logicking it out like that. But I like that algebraic way. This has been done tech active, but that is a tech free skill, and that's why I've kind of taken the time to explain what you would actually have to do in that scenario. Okay. If you want me to kind of step that out a bit more, I know I just said it out loud, so it's a bit sucky, but just let me know in the chat and I'll just quickly type it out while you guys are watching, and then you can see exactly what I mean. All right. Part C, we're trying to find when the particle is not accelerating. So, if it's not accelerating, the acceleration vector is going to be equal to 0. We let the acceleration vector equal 0. And then once again, we have this. Now, if you used nsolve on the calculator or whatever your numerical solve function is, happy days. But if this is a tech for exam, you're not going to have that luxury. So what we do is we strike out, we divide 0 by pi squared over 4. Then we're left with 0 equals cos pi on 4t. When does cos equal 0? Cos equals 0, remember that's the x one. It equals 0 at pi on half. It also equals 0 at 3 pi on 2, and so on. So you go back around and go, okay, 2 pi plus pi on 2, which is 5 pi on 2, and you just keep going. Now, that means that cos pi on 2 equals cos pi on 4t. We cross out the causes, and we're left with pi on 2 equals pi on 4 times t. We divide out the pi on 4, so pi on 2 divided by pi on 4. We have to flip it. It's going to be 2. Yes. And then we're going to have t equals 2, and then you do it again for when cos is down here, and it's also equal to 0 because that's the x-axis, and that's going to be at 3 pi on 2. If you also do that, you're going to find it 6. And once again, if that doesn't make sense to you, I'm visualizing it, but if you can't, I'll just type it out in the chat. So apologies, it's not on the slides, but that is a tech-free skill you do need to have. All right. So a lot of problems are they're gonna really like that you find a minimum or maximum. Now it might not say that. It might just be like optimization, and you have to figure it out. Or it won't even tell you. It'll be, oh no, it will probably tell you like, oh, find the maximum volume or whatever, and that's how you know. So it's actually pretty easy to do using the second derivative. This is how we optimize it because we just find the top point and that's optimized. We've got the best bang for our buck and we win. So some examples, find the greatest volume of a cylinder with a set surface area, or find the optimum number of t-shirts a manufacturer should produce to maximize profits. That's a nice one because finance is a little like forgotten topic that does like slip in. Um, I honestly forget what objective it is, but it is like, knowing that profit equals revenue minus losses, that's important, or minus expenses. So, they could link those two things up to make a question. Who knows? They have a great variety of questions that they do ask. or find the time at which tides will be at their lowest. That was something that they really loved talking about in year 11, bit at year 12 as well, but also because the tides will be like a cosine or sine graph, there's better ways to work it out. Like you can kind of just um, eyeball it or graph it, and it's kind of more effective. Now, I will note that a lot of students will actually lose marks as well for questions where you used your graphics calculator and you found the answer by doing like the maximum point, but you didn't draw a graph. If you use your calculator graphically and you use like the max function, you have to write using calculator max function, and you also have to draw the graph. It's really annoying, but otherwise you're going to lose that marks, and that would really suck. Otherwise, just do it algebraically. You might find it's a bit quicker. I hated drawing. I really suck at drawing. So, but yeah. All right, that's the second derivative. Apologies, we don't have many questions there. Optimization was covered extensively in year 11. Once you understand the general process, it's kind of just rinse and repeat. Once you work out the two equations and do your substitution, you can kind of bluff your way from there. It's a complex topic. However, once you got it, you got it. So, with that being said, do high volume and practice questions for that one. Because if you're not getting it right, you're missing out on 3 marks. All right. Without further ado, let's get on to trig. These are the basics. So you will have prior knowledge because you did year prep all the way up to year 11. Okay. Now, the basics are SOHCAHTOA, so sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tan equals opposite over adjacent. Not really, like they love to ask questions where you draw a little triangle in specialist, but for methods it was less common. There is an extra rule that you should appreciate though, or an extra two, and that is that tan equals y on x or sine on cos. Now you don't need to understand the proof for that necessarily. If not, there's a great chapter in the complete course notes book. I was recently teaching a student in year 11 from that actually, and they found it really useful. So sine is also equal to y, so y equals sine, cos equals x. So when you're actually looking at the unit circle, the x component is cos theta, the y component is sine theta, tan theta equals y divided by x. And the reason that that works is it's just SOHCAHTOA, except the hypotenuse is 1. And so it simplifies to like sine equals y. And that's because the radius of the circle is always going to be 1 for a unit circle. That's the definition of a unit circle. Anyway, and then we have these kind of like a little bit more confusing rules, just like 180 degree minus theta is sine theta, 180 minus theta is negative cos theta, and you're like, what the heck? I never learned that. That's so confusing. Basically, it's just saying that if you flip something, so we have sine, then we flip it, it has to do with the y and the x. So whether it becomes positive or whether it becomes negative. Now, I do think it's important you know the cast rule. So CAST, start in that bottom right quadrant, go CAST. And that's just to know whether the value you're going to get is positive or negative. That's kind of what this is alluding to. So the cast rule is quite useful because, if you have angle that's not in the first quadrant, you're going to be like, what the heck? Um, and even though it's going to be the same value, whether that's square root 2 on 2, etc., those are your exact values. You do have to memorize them. Whether it's triangles or you just memorize the table, I did the table. Now, if it's outside of that, you have to go, okay, I know it's going to be that number, square root 2 on 2 or whatever, because it's just a reference angle, so it can't exceed that. However, you have then it might be negative. So you found a positive number, but CAST, if it's negative in that quadrant, all you do is you put a little negative. This last part, congruence tests, congruency, similarity, not really that useful. However, it's pretty easy. It's just like side, side, side. So if they've got 3 same sides, they're congruent. Side angle side, so 2 sides and an angle, or 2 angles and which is so right we need a right angle for that. So it's actually just side. Sorry, just putting this in. It's actually except we have a right angle in there. Yeah, sine rule. This is on your data book, so don't worry about too much. But also, so you have sine A divided by A equals sine B divided by B. You can swap that. It doesn't matter because you're swapping both sides. You can swap that at any given point in time. That can be useful because otherwise you have to do a little bit harder math. But if you see that on the formula sheet, you can just flip it when you write it on your page. That's good. Also, a pretty basic rule that you do have to know is that all of the interior angles, so A, C, and B, those all add up to 180. That's part of the definition of a triangle. All right. So for the triangle ABC, find the angle BAC. Now, um, you have 5 minutes, so pause the video again, have a go. It should be fairly easy, but that's like it depends on how much work you did back in like year 10 and 11. For me, my teachers really stressed it because it comes up in year 12. For you, they may not have, and that's okay. That's why we do it at this introductory level, and then we move on to more complex examples a bit later. So have a go. Um, Sometimes you can get anyway. We'll see. Yeah, let's head on to the answer. So if we're finding BAC, BAC means the angle between. So we've got point B, point C, and then A. BA, it's the angle that's formed between B and C where they meet at A. Okay, so that's this guy up here. Now we have to use that 180 rule that we literally just talked about. They all add up to 180, so we just minus away the 32 and the 78. Hey presto, we get angle BAC, also known as angle A. For find the value of C, we have to use sine rule. Okay. Now they may have just asked us straight away, okay, find the value of C, and we would have had to use part A to then solve for it. Okay. Sometimes slightly harder questions get you to do that, which is once again why I recommend high volume of questions. I know you've got access to textbooks. Do enough questions of that so that until your eyes hurt and you already know all the stuff and you're so bored because you're getting it right each time. That's good. All right. So all you do is you just sub in what you know, solve what you don't know. Okay. The big letters are for angles. The small ones are for sides. Then our next rule that we have, this rule is also given by, it's also given by the formula sheet, so don't worry too much about this. And that is c squared equals a squared plus b squared minus 2ab plus cos c. How do I know what cos c is? Well, no, how do I know what c is? You can actually make c the one that you're interested in. No, you make c the one where you know the angle and you know the side. And then A and B, those can be your variables. You can rearrange this one. It's not set in stone, even though they may say that A is the one you're solving for or whatever. You can swap it around and do whatever you like, okay? It doesn't matter. And then if you're given three sides, could use that formula, but I've honestly never seen that before in my life, so I really doubt you'll need that for an external exam. For the quadrilateral quad means four. So there's a couple of properties of these guys. Basically, it's like we can draw a line between P and R here, and that's gonna give us two triangles, which can help sometimes. Now this one's a little bit harder, so you can have 10 minutes if you want. I try and whip through it pretty quick because you want to save that time for some of the harder algebraic questions potentially you can get um, later on in the exam. So pause the video, have a go. All right, here's the answer. So for part A, we had to find the length of PR. That's between P and R, and it's actually going to help you with the next couple of questions. Okay. Now to find the length of PR, we let PR be C. Now the reason we let it be C is because the angle of interest is 102. So that would be PSR. and it's actually like opposite. So they do this weird thing where it's like angle S is opposite to its side. So it's like think of it like opposites attract. Okay. Um, and that's why mathematically it's like the one that's opposite is the one that's also going to be the same letter. Okay. We sub it in. Um, you do have to do a little square root. Just some simple algebra. This would be a tech active question, as these mostly are. Part B, find the angle PRQ. So P, Q, intersecting at R. For this one, we're just going to use sine rule because we have, or we're finding an angle because there's two angles involved. Whenever there's two angles involved, we know that it's going to have to be sine rule. Whereas if there's only one involved, we can use cos um, to solve. Okay. So we sub it all in. Bit of rearranging. This one, once again, would be in your calculator. You have a fancy graphics calculator, so make sure you use it and check over your answers when you get all that free time at the end. You won't have that much free time, but it is a good opportunity to pick up because you'll find mistakes and you'll earn extra points by going over your calculator and going, okay, I did that, something. Oh, what did I do there? All right. Part C, find the length PS. Here we're just using sine rule yet again, bit of rearranging, which is no problemo. Now if you were asked for radians, that's fine. You would give your answer in radians. But because the question gives it in degrees, you're going to put it in degrees. Now, people mess up big time. It's probably one of the biggest things where like it's a horror story, besides like not remembering to fill in those multi-choice bubbles, and that is they leave their calculator in one mode for the whole exam, which means they're in a lot of trouble with questions like this, where it's like they're working out perfect, they know what they're talking about, but they've got it in radians, not degrees, and they're just missing that mark every single time. Every single time. Okay, so we just rearrange and make sure your calculator is in the right mode. Right, area of a triangle. So you've been taught from like year 7, 8, back when math was boring, that an area of a triangle is given by half times the base times the height. But using trig, and you don't really need to know the y here, we can actually kind of figure out another rule. Now, I'm pretty sure this one's not on the formula sheet. I would have to double check. I'm not going to, but you could by just pulling up your data booklet. If you can't see area equals half BC times sine A, I'm pretty sure it is in there actually. I'd say yes. Um, you might have to commit this one to memory. So write it down in your formula sheet, memorize it the night before, no worries. Um, and this now you can see that we're talking about B, we're talking about C, and then sine A. So we've got these two sides, and then the angle that's not associated with those sides. So side, and then the angle here between those two sides that's not associated with those two sides because it's opposite to the other one. So um, A, the side A would be here, which is opposite to that angle. That's what I was talking about before. And to work this out, all we need are two sides and an included angle. So it's arguably better than having to find the height of the triangle. Often you're going to have to use this rule to work it out. Now, don't be afraid in an exam to have to, have a bit of a, you look at the question, you're like, oh gosh, for some reason my mind's like, that's fine. Everyone has that during an exam. And it doesn't mean you're going to do better, you're going to do worse. It's going to happen regardless. So, what's your coping mechanism when that happens? That's the more important thing that I want you to get out of today. And that is, you pull up so you got your formula sheet in your hand. You're holding it in a fist because this is important, right? Now, you see the question, you're like, gosh, I've done a bazillion of these questions. Why can't I think? What you do is you go to the formula sheet, which is like your sheet notes you've got in the exam, pretty much. You flick through and you find whatever formula looks the most relevant. Fortunately, here it's going to say area of a triangle, and even though you're thinking, "Oh, area of a triangle, oh, that was like base height. Like, why? We don't have the height here. Like, how does that work?" You're going to flick through. You're going to see this sine A formula, and then you're going to go, "Oh, we've been given an angle. We've been given this. We've been given that. I'm going to be able to figure it out. Okay. Don't be afraid to, feel confused at times. That's okay. It's about how you deal with that confusion. All right. So here's an example. Once again, pause the video, have a go. The answer is here. So if we're finding an area here, firstly, we're going to have to find an angle. So you would look at that problem and you go, oh, crap, I don't have an angle. Um, I've only got three sides. Fortunately, you know that if you've got three sides, you can use the cos rule, sub in B, C, and A, and then solve for the cos A. All right. As you know, cos A is this guy here. So 8 would be little a, big A, which is the angle, is going to be this guy over here. Okay. Once you've solved for that, all you do is you sub in the different values, B, C, etc., into the formula, and hey presto, there's your area. Okay, so really easy marks because this is pretty mark heavy, relatively, considering all you're doing is like using two different formulas that you don't even have to memorize, and you're just directly subbing it in. It's pretty high yield, to be honest. Make sure you know this stuff. All right. So these are the complex familiar and unfamiliar applications that you may experience. Bearings come into it. I hated bearings. So knowing that the true bearing is from north and then we go clockwise, or east, south, all of this, north, east, southwest. Knowing that, you can kind of figure it out to an extent, but we will go through some of these questions in a bit. And then angles of elevation and depression. Elevation, we're looking up. Depression, we're looking down. That may just make intuitive sense to you. Problems in three dimensions is complex unfamiliar, very high yield. Hasn't been asked to super a lot, which is why I think yours it may be asked because you have to have a pretty like spacey understanding to be able to do it, which does separate students quite significantly. We also can have like angles between planes. I forget whether when I wrote this I was talking about planes as in planes or planes as in like different planes and because a plane is like a surface. But they do like planes questions where they have or this boat is moving this way, this is moving that way. Okay, when are they going to intersect? Are they going to intersect? How do you look at that? It can get quite complicated, quite convoluted. Fortunately, the textbook that your teacher has given you is very good at giving you convoluted questions. So look at that, and I'm sure you'll find some hard questions which you can go over if you're like, I feel like I haven't done enough practice on this. So we need to know those base rules. You need to have that understanding down pat before we can go into those questions. Okay? So if you didn't get those ones before, maybe this next part is going to seem a bit tough. And you know why? Because you haven't got the basics yet. And that's fine. I just recommend maybe watching the first part again, looking on YouTube, looking at all the free resources we've got available, etc., etc. Right. So complex unfamiliar example. Find the angle of C or C apostrophe. We're going to talk about what that means in a sec. A and D apostrophe. Then find the angle of um, of that shape, of that triangle rather. And then we got these little variables. So as you can see, this question looks rough. We look at this and we're like, what the heck is going on? And that's why it's complex unfamiliar. Super duper high yield, because once you know what you're doing, the marks aren't that hard. Like conceptually, it's out there, but once conceptually you understand it, it is high yield. It's good bang for buck. All right. So first of all, what is going on? This diagram is a little bit better here, actually. Finding the angle. Also, so give yourself 10 minutes, I'd say, for this one, because it is a complex unfamiliar. It's probably not whack. I call them whack questions, where they're the external question that no one in the state gets. I don't think this is whack. It's quite doable, but it is definitely complex unfamiliar, which means you get this, you're scoring in the 80s, 90s. All right, so find angle CAD, or C apostrophe to A. So this apostrophe stuff is just to confuse you. C apostrophe to A to D apostrophe, which is over here. So basically like that in this kind of plane. All right. Now we can find the length. The length. This is something that potentially could be worth kind of appreciating. Now, if not, how on earth would you figure this out? It's actually Pythag. I know. Oh, what's Pythag? Oh, Pythagoras theorem: c squared equals a squared plus b squared. Essentially, when we have these right angles, which, by the way, happen inside of a prism, this is a rectangular prism. That means we can use Pythag. Essentially, a to not to d apostrophe here, to find the length of AD here, we're gonna add x, which is it's like rise. We're gonna square that plus 2x squared, but we're gonna put a square root on that because we're looking for the hypotenuse, and we don't want c squared, we want c, so we're gonna put a little square root there. That's how they've derived that kind of working out here, if that makes sense. But if you need further explanation, query away, please. No, ask in the live chat, please. Yeah, so then they simplify. Fortunately, it does simplify fairly nicely. And then they do that with AC as well. And then we go, sorry, it's just been cut off a little bit. Come up here, kind of a bit lost to where this is from. That's just 20, square root 21 times x, because the square root of that is just x. I think that's just an elaboration of that over there. Not sure what that line corresponds to. Yeah, okay. So now we've basically figured out these two things. Okay, that's we were figuring out AC and we're figuring out AD. Why do we need to know that? Well, now we can use a sine or cosine rule. Now, if we've got two sides and a third, and we don't have an angle, what are you thinking? Probably cosine. Well, we could use cosine to find one of the angles. But that being said, like there are different ways you can go about it. Here, I would have done the hard way, which would have been cosine, but you can also use sine because the angle CDC is going to be a right angle once again, just due to the nature of this prism that we're talking about here. So we sub everything in. We've got x's. Fortunately, the x's actually cancel out. So if you were doing this question organically, you'd be thinking, well, how on earth are we going to get rid of these x's? We haven't been given any more information. Fortunately, it just cancels out, which is why it's important not to try and I don't know I'm just looking at this question, I can't figure out the last line of working out. And then being really frustrated. Just work it out step by step. Do it sequentially. Your only thought should be, okay, what do I think the next step is going to be? Because at worst, you're going to get part marks. X is cancelled. That's the important part here. Sine 90 equals 1. That's one of our landmarks on the unit circle because it's up there where y is equal to 1. That's the maximum point for y. Now part B was find the area of triangle ACD. Now this part's pretty easy actually. All you have to do is sub in the parts that we know into the area formula. This time the x's don't cleanly cancel, and you're like, oh no, they should be canceling. Just leave it as is. The correct answer is actually with an x squared here. That's what the question is asking for. Because, we can't find the area unless we know x. Otherwise, this could be it's got infinite dimensions. The area is not going to be constant for all of them. So, therefore, the area is going to have an element of x to it. All right. Oof, that concludes our trig and probability. Let's get into trig and second derivative. It's pretty heavy. Well done for sticking with me so far. We got about just over an hour left. Hopefully probability will go a little bit quicker, just the intro part. All right, so what are we going to do? So this is probability section number 1, intro probability. What are we going to talk about? We're going to talk about the binomial distribution and continuous random variables, okay? Firstly, binomial distribution. So binomial distribution and Bernoulli sequence. Same diff. These guys are the same, all right? So a Bernoulli sequence is a sequence of repeated trials with the properties, and these three things you do actually have to memorize. So it's not often that you have to kind of, that a question will say, explain or what are two Bernoulli conditions that have been met here? Here, you might actually be asked that. Sure. They might actually go, okay, um, is this a Bernoulli trial? And you have to actually justify why or why not. So, firstly, each trial has to have two outcomes. So, it's got to be success and failure. That doesn't mean that it's always like true or false. It can be like rolling a die. And is it a six or is it not a six? So, even though there's six possible outcomes and different probabilities associated with all of them, we can like break it down into is it a six or is it not a six? Okay. And this is how some students kind of get mixed up because they get confused and they're like, well, way more than two options. But if you're looking at one thing, it kind of like narrows down to kind of like an absolute where it's like yes or no. Okay. Is it that thing or is it not that thing? And when you're answering questions like this, it's super duper important that you go, okay, this is a Bernoulli sequence. Let success be blah blah blah. And then you define all of those so that you can then plug it into the formula that's on the formula sheet under binomial probability. Because binomial, Bernoulli, potato, they're very related. Obviously, we wouldn't say, oh, a binomial sequence was conducted. We'd say a Bernoulli sequence. Secondly, the probability for success of each trial is constant. Now, otherwise, it's not a trial. Think scientifically. So, if the probability is fluctuating, that means it's unreliable. It's not very scientific because it's not very repeatable. So, for it to be a trial, it has to be specifically repeatable. Okay? So, probability needs to be constant. Otherwise, it gets way too complicated, way above your pay grade and my pay grade. Three, trials are independent events. So if the first trial is a failure, that's not going to affect the second one. So, soccer game, sure, let's say the probability of scoring a goal is like 0.2 or whatever. They score a goal. Now, what you'll find is that those are actually not independent events, they're dependent events because the goalkeeper is going to be feeling down or because there's this human kind of emotional element. So you would probably argue that that's not a Bernoulli sequence. Yeah. So the number of successes of a Bernoulli sequence of a certain number of trials is called the binomial random variable. So as soon as we're like looking at success and failure across several trials, we call it a binomial random variable, and then we get some more interesting math happening. And this is where that x comes in. So we can distribute it on a graph and we kind of give that value we give it the name x. So once again, prior knowledge, permutation and combinations. You may have done this in year 10. If you do specialists, you've done this in year 11 and you're like, oh, I don't want to see this. And you don't really need to know it oh so well. It's more about knowing, and as I recall, the Head Start lecture from I want to say April, but I'm not thinking it's April. Maybe it's like June or something. Have a look at that. I think it was April because we went over it and I actually did the proper triangle and said, okay, this is what you need to know. Go back to that. This is just recap at this point. Okay. If you do know your permutations and combinations, that's fine for you. But it's called Pascal's triangle. So just Google Pascal's triangle right now, and then you should be able to know how to draw that up to like 10 levels or whatever. But you'll find it's very easily extrapolatable. So we use this formula. You're probably thinking, where on earth have we obtained this formula from? And this formula is on the formula sheet, but you do need to know what each of them mean. Okay. So big X is like the distribution. Remember the weird kind of definitions where it's like X equals X. It's like, what? Little x is the number. So the thing we're interested in. So if we want to find out whether, what the probability of getting, um, you know, 3 rainy days out of 10. N would be 10 because that's the number of days. Little x would be 3. And then big X is like the variable. So big X equals little x because little x is the specific point on that variable. I know it's really confusing, right? Just know what to sub in is all you have to know. You don't have to have a brilliant understanding, right? And then we can use this kind of combinatorics formula or combinations. So this thing here with the bracket, this is the combination. this is the Pascal's triangle. So, knowing that n comes down, x goes across, so r and n on Pascal's triangle. So we have this triangle is like 1, 1, 2, 1, and then we keep going. So we just fill in the ones and then add up the two kind of like parents. We just add them up, okay? Make that triangle. We then look n's going down, so 0, 1, 2, 3. Then we have r or x here going across. And then we work out what that specific number, because it's going to be a specific number, actually is. Okay. You can also use your calculator. I know for my T-Inspire, it was you went NCR, like you type NCR bracket, you put the N number, then you went comma R. Use Google, look at your instruction guide, ask your teacher, do ChatGPT, work out how to do that because it is useful not having to do Pascal's triangle each time. Example. Is rolled 6 times. There is 1 3, 2 5s, 2 3s, 5 3s. Okay, so take 5 minutes to do this. It is important. This is simple, familiar content still at this point. So it is important that you know how to do this because it is really going to be the foundation of you passing math methods, which is definitely an achievement. Math methods is not easy as you're well aware. Anyway, all right. So take a couple of minutes, have a go at that. Here are the answers. So all you do is you sub into the formula. Really annoying that the formula isn't here. Apologies for that. But all we do is sub in. So this first part would be the combinations thing. And then we've got the probability. So it'll be like x minus this, or, if we go back to the formula, 1 minus p. P is the probability. Graphics calculators are your best friend. Okay, you should do better on the tech exam if you've properly learnt how to use your graphics calculator. Okay, here's an example from the textbook where they really go through this for a T-Inspire. A non-CAS means it can't cheat and do derivatives and stuff like that for you. RAD for radians too, by the way. And yeah, binomial PDF, you kind of just tab through it. You never write it out, and then you put in all the things. When you go through it, it just pulls up with this like little thing. It's like, well, how many trials are there? And you fill that out. That's why the tech exam, like, if you use your calculator properly, it can become very easy. Now, I'm not going to speak to it too much, just because other people have different calculators, which means that you're going to have entirely different processes for how to work this out. Please hop on YouTube. Please know how to do. If you see something pop up and you're like, oh, I don't know how to do calculate probability of a binomial sequence, binomial distribution, watch a YouTube video. It's all freely online and available. You are going to save yourself. You are going to get the best marks ever on that tech exam if you do this properly. All right. This is for the Casio. Um, Just follow those steps. I'm not going to speak through it because everyone has different calculators. All right, further questions. So sometimes we're interested in not a discrete number, so like how, you know, 3 days out of 10 are rainy, but we're interested in more than 3 days out of 10 are rainy. Okay. So we're not finding probability x equals 4. We're finding probability x is greater than 4. Or probability x is less than 8, etc. Now we kind of have to do this by hand, to be honest. I'm not sure. I forget. We're not going to talk about this very much, so it is important I talk about it now. And that is, like, if we had probability that x is greater than 1. Well, the probability that x is greater than 1 equals the probability it equals 1 minus the probability that x equals 1. Okay? So you kind of use these absolutes where it's like, well, it's either 1 or it's not. If we're trying to find it more than 1, don't add up or probability that x is 2, x is 3, etc. No, you would go, what is the probability x equals 1? You'd also have to do probability x equals 0. Sum those are, or then minus them from 1, because remember, all probabilities got to equal sum up to 1, and that's going to be your answer. Okay? All right. Right, and then this is how we would then do that. So it's not PDF this time, it's CDF. This is exactly how I did in my calculator. You just sub in the values, the upper and lower, sub it in, bingo, there you go. This is for Casio. This should cover most of you guys. Just pause the video, have a look. More specific questions, let me know in the chat. Now this is a bit of an extensory type. It was in year 10, so of course you can have it assessed. And I'm pretty sure it's actually something you have to memorize. So the binomial distribution may be used in problems involving conditional probability. Now you need to recall that the probability of A given event B has already occurred equals the probability of A and B divided by the probability of B. And then this little like intersection thinger is like and B. So if we had a Venn diagram, it's going to be that intersection point there, isn't it? You do need to memorize that. So write it on your data booklet. You may not. I'm pretty sure you have to memorize it. But then again, I get confused with specialists because specialists they're more limited with what they give you guys. So write it down anyway. It's important to know the notation, unfortunately. So probability of A given that B has already occurred, and then we divide by B there. All right, here's an example. There is a 90% probability that any given person is right-handed. In a classroom of 26, find the probability that there are 20 right-handed students given that there are at least 12. Okay, so first, or like spend a minute or two going over this. I'll give you 5 minutes. Pause it, set a timer, 5 minutes, have a crack. Here's the answer though. Basically, we fill in what we know. So probability equals 0.9. So success failure, they're right-handed or they're not. So it is a Bernoulli trial. N equals 26 because that's the number. And then the question is, we'll find the probability that X is 20 given that there's at least 12. So given that X is greater or equal to 12, what is the probability? So we actually have to sub into the formula, which is directly into this formula, the given formula. So what is the probability that X is 20 given X is greater than 12? Well, we sub in for A and B, so probability that X equals 20 and X is greater or equal to 12. Now, isn't that strange? Oh, probability X equals 20 and is greater or equal to 12. That greater or equal to 12 is irrelevant, isn't it? Because if X equals 20, that means that it's going to be greater or equal to 12. So that's actually just equal to the probability that X equals 20, isn't it? We then divide by the probability that X is greater or equal to 12. Now they've skipped the substitution here, apologies, but you would then do a little scribble with your, you'd either use a calculator, hopefully it's in the tech exam, or you would then like do your little scribble out the formula, work it out. All you do is you sub in P equals 0.9, N equals 26, and then the different values of X. This one would probably be tech, just because it's a little bit too big, isn't it? It's a little bit too big because you have to do probability X equals 1, X equals 2, etc., etc., to actually work out what the probability is greater or equal to 12. Simplify it, and there we go. All right. To make predictions about a binomial distribution, we may wish to determine the expected value and variance for a given number of trials n with probability of success p. So these guys are just on the formula sheet. Expected value is ex, and that's just n times p, or this little mean symbol, okay? And then variance, remembering that variance equals the equals the square root of standard deviation, I think. But we'll go over this in a bit too. And that kind of helps us when, like, if they ask for standard deviation, you're like, oh, there's no formula. You use variance, and then you either square it or square root it, I forget. All right. Example question, take 3 minutes to do this. Pause the video. Find the mean and variance of the binomial random variables. Okay. All you do is you just sub in n equals that, p equals that. Nothing too difficult there. So often you may wish to know how many trials you need to conduct to be reasonably sure you'll get a certain number or range of desirable outcomes. For instance, you have a binomial distribution with a probability of p equals 0.35, and you want to know how many trials are needed to make the probability of at least one success greater than 95. And it just gets so wordy, right? Like the first time you try some of these questions, it seems so wordy, which is why volume, 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 guys. Make sure you're doing your volume of questions because it does eventually make sense. I promise you that. Everything will eventually make sense. You just need to do volume. Maybe you slacked off during the year. That's fine. Not too late. Even if you're slacking off in now, you're doing the right thing watching this video, and it's not too late to pull everything back from the brink. So, this question is a bit harder, right? What we have to do is we have to break it down into things we know. So we want we're gonna have to sub in a 0.95. We know that. So the probability has to be 0.95, and x is going to be at least one. All right. So here we see what is the probability x is greater or equal to one, and that is going to be greater or equal to 0.95. Now, we have to simplify into stuff that we can actually physically work out. So the probability that x is greater or equal to 1 is going to be equal to 1 minus the probability that x equals 0. Because we kind of think about it as like a Venn diagram. It's like, well, if x is greater or equal to 1, the only other thing that's not greater or equal to 1 is 0. Okay? Now that we've got it in a discrete x equals this specific number form, what we can do is we can actually use our binomial sequence formula, which is just in the data booklet formula sheet, sub that in, and now we have this weird like n thing. So the variable that we're missing here is n. So when we break this down, we've got our combination, we can work that out, but we don't have n, okay? Or we don't have the combination either. Um, yeah, we wouldn't actually have the combination. Oh, no, we do. Um, oh. Now, I don't know if you guys did watch my video from April. Pretty sure it was April. Go back and have a look at that because I remember that I specifically went, oh crap, what do you need to know? I put a little red box and it said there were the combination rules, the ones to memorize. And one of them was NC0 because N, we don't know N. C, that's just combination. 0 is the R. Because R is 0, that whole thing is just going to equal 1. Okay? That's why there's not this confusing NCR stuff. It actually simplifies nicely. Okay? So, go back to that PowerPoint, go back to that video, watch it again, and you'll see this come up. Because I did go over this in a little bit more detail. Like I said, this is forming more like of a revision as opposed to this is the first time you're seeing it. First time you're seeing it, I recommend watching that other video. Also, it'll help you with your unit 3. Okay, now what we do is we just simplify, minus the 1 away. We got 0.65 equals 0.05, or the less than rather. Now, I would just use nsolve at this point and then like work out in my head, okay, because of that less than sign, I know that it's either going to be greater or less than 6.954. What is it actually going to be? And kind of use a bit of logic to go, okay, well, it's likely going to be it's going to be greater than, okay? But if not, you can keep the nice notation. You only ever swap the side, so the direction. It's like a little crocodile head. You only swap that if you're like dividing by a negative or flipping and then and you know that's the like if we can even do like functions like logs across it and it doesn't really affect it. Now as we can see, n is greater than 6.954. That rounds up nicely to 7. And hey presto, we're a happy Larry. Right. Suppose we have the same situation, p equals 0.35, and we want the probability to be greater than 95, but we want at least 2 successes. It's fine, okay? We sub in greater less than 2, sub that in. Just this time, you know, when we actually work it out. So the probability, so now we have to make this kind of a bit of a logical jump because we don't want to do probability x equals 3, x equals 4. We can't add up far. We have to do the inverse of that, which is to go 1 minus 0.95 to give us 0.05. Okay. Then we go, well, if it's greater or equal to 2, what numbers are not greater or equal to 2? 1 and 0. Okay. So all we do now is we just add up probability x equals 0, probability x equals 1, sub that in. Obviously, this is extremely painful, right? You're not solving this. Sorry. So what you would do here is whack that in and solve and then go, okay, well, are we going to have a less than for trials or is it going to be greater than? And if you think pretty logically, you're going to go, well, trials is a minimum, right? We're looking for a minimum, so it's going to be greater than that point. Okay, and so it's usually going to be a greater than sign. I can't think of any examples where it would not be right now. Sorry, I jumped the gun. Oh, what now? Now you would use the numerical solve function. And all your calculators will actually have this function built in. It's nsolve for, oh gosh, that is an interesting formula. Of course you can do that. Now I never learned this. I would actually have, if I was given this was my thought, or you would probably just sub it into nsolve. Nsolve, comma n, so the numerical solve, and then just work out in your head, okay, trials is a minimum, so it's going to be greater than. Because we're going to have more trials than that. More trials is good, not less trials. But you can also do this. It is relatively low yield though. You can just use nsolve or numerical solve because that is something that I really, really hope you have familiarity with. If not, ask in the chat. I'll find a link for how to do it because you've been living under a rock and living it quite tough actually, not using nsolve. All right, this is how you do it with Casio. But you can also use the numerical solve function as well. All right, that's enough about binomial variables. We're now going to move on to continuous random variables. So far we've kind of looked at discrete things. So discrete is like definite, not continuous. So where it's like success or failure, there's only set options. So, there's only going to be one success, two successes, three successes, four successes. We can't have 1.02789 successes. So continuous random variables are numbers that can have any value within a defined interval in a set of real numbers. That's a whole lot of gibberish. Basically, it's like, we can't say for certain that it's exactly this because it's going to be slightly either side of it. So distance, for example, we can only measure up to like a micron or whatever the small measurement is. But in reality, it's actually like way, way, way more detailed than that, beyond what we can measure. Okay, we know approximately it's here, but it's not exactly that. Nothing's ever been 10.000 for infinity centimeters. Nothing. So the things we measure, they're actually typically continuous, and some good examples are distance or time taken or height. Okay, so data, if we've collected data, we can approximate a continuous random variable. And the key thing here is that we have these little bands of data, and it's in a histogram form. So because it's continuous, if you find the probability that it's at one specific point, nothing in the history of ever has been that one specific point, just because it's that detailed. It's such an abstract concept, I know, but it is important that you understand this. Probability that x equals x for a continuous random variable is 0, okay? But if you find 2 points and you're like, well, between 1 centimeter and 2 centimeters, then there's a definite probability that it's going to lie in 1 to 2 centimeters, okay? So like this shaded area here is like a band of data. So as the sample size increases and the interval gets narrower, the histogram approaches a smooth curve. So then our approximation becomes more and more accurate. So, if you're using a smaller and smaller interval, it's going to be more accurate and less awkward and blocky, right? Now we call this a PDF probability density function. Density because it's like we're looking at these bands and the density of the probability in them. So the probability density function would be the red line that's approximating this histogram, okay? Because the histogram in itself isn't very accurate, is it? Because we've got these bands and it's not very specific. But if we model a curve based off that, we can get really specific and extrapolate that to smaller and smaller intervals or more specific intervals or whatever the heck we want, right? Um, yeah. So there's two probabilities of a probability density function. Now write these guys down because they are 100% high yield, as in these may well be a question, and I'm sure if you've done textbook questions before on this topic, you've seen where you've had to use this. So um, there's two main properties, and you may have to explain why something's a probability density function. I think I remember a past paper question on that actually. Now, something's a probability density function if the probability is always positive. So the function fx, which is the PDF, is always above zero. Okay, that kind of makes sense. But for it to be a probability density function, between the minimum and maximum bounds, the probability has to add up to one. Once again, kind of makes sense. However, if we can actually use this property to solve for maximum and minimum bounds or etc. Okay, so we can actually solve for different variables by going, okay, well, we know that between the whole thing, the integral of that, which is how we find probability. So the area, remember the area under a curve to find the area under the curve, remembering that the area under the curve here, or the area of this histogram box, that's the probability. I know it's super abstract, but we can then use that little integral, integrate it between those 2 points, and then we might have like a value, variable like t or whatever. We can solve for that using the probability that using this kind of rule that between the minimum and maximum bounds, all the probability adds up to 100. So we kind of use that in some questions. Here's a classic PDF. As x would be the different measurement values, whatever it is, whether it's time or whatever. Um, and it's never negative, it's always positive, and often we see it stepped out as like we see it stepped out where there's like two different equations, and that's fine so long as they meet up and marry up really nicely. That's a-okay. So part A, prove that f of x is a PDF. Part B, find the probability that x is less than 1 where x is given by the PDF. I've got that. I'll give you 5 minutes. Classic question. This is still simple for me. Right. Okay. First, if we're going to prove it, we need the two conditions. The first one, between the minimum and maximum bounds, does it add up to 1? The maximum bound here is infinity because we're just going x is greater than 0. Okay, so from 0 to infinity. The 0 part, so the second part where it's less than 0, we just really don't care about that. So we do a bit of integration, have to pull it. This is a bit of a bipattern chain rule. We have to divide by the -2. That gives us this. This is weird notation, but it's basically saying, oh, well, this is our integrated function, and we're now going to put it between 2 points, which is 0 and infinity. Now, you have to use a bit of logic and go, well, negative e to the power of a ridiculously large number that's negative, it's going to be ridiculously small, i.e. 0. Minus e to the power of 0. Anything to the power of 0 is just 1, so what 0 plus 1 is 1. So it does add up to 1. So yes, it's a PDF. The other one, you'd probably write as a sentence, because it never dips below 0, it is a PDF. You would also have to write that. Part B, find the probability that x is less than 1, where x is given by f of x. We just sub in 1 here. We're basically finding the bound between the minimum and 1, because we don't care about below 0. So we go 0 to 1, integrate, sub in, hey presto, 0.86. We can also use our graphics calculator, remembering that if you are using your graphics calculator to graph something, make sure you actually graph it, just quickly do a sketch, because otherwise you will lose marks. That's what I was talking about before. Now you can use just like here, this is the calculator I used. Oh dear, what have I done? So you just literally do the integral. It only works for definite integrals, but you can also use the nsolve function to let's say you had like a variable a that you're solving for. You can actually use it instead of having to do some pretty hard algebra. But yeah, we can map the piecewise function, etc., etc. Um, Make sure you contextualize this to your calculator. Right, so like with discrete random variables, we may wish to find the mean or expected value of a continuous random variable. Now, if we're doing that, we use this formula. Oh no, what's that formula? This is just on your data booklet once again. If you ever get lost, just go to the data booklet. More often than not, the formula you're looking for is just there. And if not, there will be a formula for the next logical step that you have to do before you then work it out. Okay. So, for example, standard deviation, you have to work out variance first, et cetera, et cetera. So we basically integrate it between the minimum and the maximum bounds. The only little cheeky modification we do is we multiply f of x, which is the PDF, by x. Um, then if we're finding, oh yeah, and then if it's upper or lower bounds, which it often is, instead of being negative infinity and positive infinity, it's a and b. Remembering that with those infinities, you're going to have to do a bit of logicking where you're like, okay, is this, it's usually going to be 0 or 1. Is it going to be a ridiculously large number or a ridiculously small number? Which is going to affect whether it's going to be 0 or 1. Okay? All right, example question. Find the mean of a continuous random variable with its PDF given by f of x equals 0.5x between 0 and 2, and then otherwise, which just means like anywhere not 0 and 2, it's just going to be 0. I'll give you 2 minutes for this one. So pause the video, take 2 minutes, set your timer. The answer is here, so we just go between 0 and 2, remembering that we got this cheeky little mod, which is we have to multiply the thing by x. A lot of students will just forget that. We do it between the upper and lower bounds, which is 0 and 2, because we don't care about the 0, it's irrelevant. We integrate that function, it goes up to x over 3, x to the 3. We then divide it by 3 as well, so the 0.5 remains out the front, but it's now divided by 3, and then we sub in between 0 and 2. That simplifies, apparently, to, actually, it would actually simplify to 4 on 3. Just quickly in my head. Guess what? Your graphics calculator can do this too. Surprise, surprise. Your graphics calculator is your best friend. Not your dog, your graphics calculator. You're going to smash the tech active exam if you have done the volume of questions with your graphics calculator. If you don't know how to use a graphics calculator, you're screwing yourself over for nothing. It is so high yield. Knowing all the little tricks to do for your graphics calculator and being able to work with it, you're going to be in trouble if you don't know what you're doing with your graphics calculator. So we just define the function. It's a nice thing we can do actually. This is really really nice. I honestly wouldn't think of this. I would probably be lazy and do it. And I'd run out of time in an exam. That's why we learn to use features like the define feature. Then we learn how to use the actual integration feature. Right. This is how you do it with Casio. Right. Percentiles. This is a little bit off syllabus, a little bit. It's conceptually out there. I kind of didn't really have a strong concept of percentiles and quantiles, but kind of got a little bit lucky in the exam, I suppose, because it didn't come up. But I'm going to go through it with you today because it is mentioned in the syllabus, unfortunately, which means that it is important that you do know what it is because they can test it. Okay, so percentiles are like percentages, kind of. So the equation below can be solved to find the qth percentile, p, of a distribution. So, for example, we want the 75th percentile. We make q be 0.75, and then we solve the p that gives that 75th percentile. So the probability being, we hit that 75%, we can then work out what point we hit the 75 at, if that makes sense. So, given the probability density function, f of x third e to the x3. Find the value of x for which 90% of the values fall below it. Oh, sorry, you can have a minute to solve this one. Set your timer for a minute. If you don't, that's fine. Like 2 or 3 minutes is okay as well. In essence, you just have to recognize that you just have to sub it in. And then you just simplify, rearrange, and solve. Really nice question. Um, so yeah, equals zero point 0.9. When does the probability equal 0.9 for 90%? You integrate, you sub in, um, an end solves or a numerical solve function would be really useful here. But if you don't have that capability because it's tech-free exam, you would have to know how to rearrange your logs and stuff like that. If in doubt, just leave it, like if you left it in the -3 times ln 0.1 form, that's a-okay. If you're in a tech-free exam. Right. This one is high yield, to be honest. The median is something we you do see come up a fair bit. It's like the interesting percentile because we don't really care about 90% so much. So the median is the middle percentile. It's kind of like the average. It's a measure of central tendency. So if it's in the middle, it's like at the halfway point, right? So that means the probability that x is above the median is 0.5. Probability that x is below the median is also 0.5. Do whichever one has a nice and easy upper or lower bound, if that makes sense. So don't make it hard for yourself. If one of the bounds is infinity and you don't really know what you're doing there, first of all, watch a YouTube video for it. And it's either going to be 0 or 1, so just work out whether it's going to be incredibly big or incredibly large, incredibly small. Um, but you might choose the one with the nice, like the lower bound is just 1 or something. But you do need to, so there's no formula that says, oh, probability X. You need to say let M be median. Um, then you have to write a line that says probability X is greater than the median equals 0.5. Now, the reason they've written it here, this could confuse you. Probability X is greater, less or equal to the median. It doesn't matter whether you have an equal than sign here because the probability at the specific point is 0. Now, that's what I was talking about before. Because it's not discrete, it's continuous. Nothing has ever been exactly bang on that point. Variance is a measure of spread of a distribution about its mean, and for a continuous random variable, it's given by this. That first formula isn't useful to you. It's this second one here, which is on your data booklet. So you first have to actually solve for the mean, and then you got your lower and upper bounds. Now, this is interesting, this one. So don't worry about this computation or anything. Like we don't really care about that. But this is interesting because it's yield, guys. You'll get three or so marks for actually sitting down and doing this, even though it's just like formulas. By having to do all those steps where you have to first work out the mean, it's got a high density of marks. Um, the other thing I will briefly talk about is this here. So this little guy here kind of looks a bit like a snail. This is the standard deviation. So variance equals the square root of the standard deviation. Oh no, variance equals standard deviation squared. Okay, so if we if we're given the variance, we have to take the square root of that to work out the standard deviation. Pause the video, write that one down in your formula sheet because that is really important. Because a lot of students kind of miss marks that they deserve and they honestly are very capable of because they'll forget something like that and they'll read a question that says standard deviation, they flick through the formula sheet, they can't find standard deviation, and so they give up, right? Even though they could have done the steps for variance, and then even if they're, but because the question doesn't ask variance, they just get 0, which is why these little marks are actually disproportionately weighted, in my opinion. If you hear standard deviation, think variance, okay? Think I got to square root the variance, okay? Write that on your formula sheet. Converting between standard deviation and variance is very, very, very doable. So yeah, standard deviation equals the square root of variance. So you first find the variance, you then square root it. and then that is going to tell you what the value of the standard deviation is. All right, so example question. The amount of time customers need to wait in line at a cinema is given by f of x equals kx times 100 minus x squared, and then otherwise it's worth 0. So first, find the value of k. How are you going to do that? Maybe have a bit of a think. I did just talk about it just before. B, find the mean of the distribution. C, find the standard deviation of the distribution. I'll give you 5 minutes for that one. I'm going to move on to the answer now. So to find the value of k, we have to do that little trick, which I was actually talking about before, for harder type applications, which is where we go, well, because it's a probability distribution, given that it's a probability distribution function, between the upper and so between the lower and upper bounds, the probability is just going to be 1, yeah? So we can actually use that fact to our advantage and solve with this integral, and therefore solve for k. So a bit of algebra, remembering that k is not an x, it's just like pretend it's just a number. So we kind of just ignore it when we do our integration. We don't really care about it until right at the end, okay? And then we solve for it. I don't really like this. Oh, there we go. Oh yeah, and then so we just leave it out the front. Do our standard integration, solve for k using that 1, and there we go. B, find the mean of the distribution. You're just substituting into a formula here. Nice and easy. Okay, just subbing in. Sure, you'll make easy mistakes. That's honestly where I lost all my marks. It's just simple mistakes. Just quite a lazy mathematician. Conceptually fine, but I just get lazy and make dumb mistakes. C, find the standard deviation. Now, if you didn't, let's just listen now. Just now, you would have gone, "Oh, standard deviation." I'm going to look at the formula sheet. There's no standard deviation on here. You have to have memorized standard deviation equals the square root of the variance. So you first find the variance, you then take the square root of the variance. Okay. Um, so if we're finding the variance, they've done this weird formula computationally. You don't need to know this, guys. Just use the formula on the formula sheet, honestly. First, you have to work out the mean. Now, it would actually be a complex unfamiliar question if this question was like, they blanked out A and B and they were like, "Oh, find the standard deviation." Because you would have to do steps A and B. So you can imagine that this is extrapolatable. It's the same skills each time, but you can have complex examples which are worth, 4 or 5 marks, which don't require any further skills, which means that it's high yield. Right. Cumulative distribution functions, CDF. So a cumulative distribution function, CDF, gives the probability of getting a certain value x or less on the defined interval. So it's the PDF, but this time we're going, okay, it's getting that value or less. So it's kind of weird. It's another abstract concept that you kind of just become familiar with. They're never gonna it's not really so contextualized as in they're gonna the way it'll be worded to you is they'll directly say, oh, calculate the cumulative distribution function and then find the probability that it's less than this, and then you just sub it in. It's essentially just a shortcut, right? So if the PDF is defined as f of x on an interval c to d, the cumulative density function is given by capital F of x, okay? Capital F of x, the probability that x is less or equal to x here. Now, we have to do this weird stuff where we add in this variable t. You're like, where did t come from? Essentially, because we're interested in the x, we have to make the old variable into a t, okay? Now, this is, once again, quite a classic question just because it involves integration. It's kind of a merging of these topics once again. Okay. Now, this formula, I think you may have to memorize it, honestly. Write it down for now. I can't remember, but I'm pretty sure you might actually have to memorize it. So I will note also that C is the lower bound. So whatever the given lower bound is, X is the thing. So we're looking between C and X. what is it? And what you'll find is that this whole thing here simplifies to like 10 times x or something like easy. The notation is weird, but when you physically go through and step it out and work it out, it makes a whole lot more sense. So let's get right into that. So given this PDF, find the cumulative density function of this distribution. Then find the probability that x is less or equal to 8, or greater or equal to 8. Then find the probability that 9 is greater or equal to, that x is greater or equal to 9 and less or equal to 12. So first, cumulative density function. All we do is just sub it into the formula. So we know you've memorized that big boy formula there. All you do is you grab that formula and you sub in what you know. So we sub in the equations of 5 divided by x squared, like I said before. The old x now becomes t, so we let it equal t, and then we just and then we look for our lower bound. So our lower bound is going to be 5 here. So we go from 5 up to x. So 5 divided by t squared. We solve this integral using a bit of a by power rule. Raise the power by 1 means it's just -1, but that's where our negative here comes from. Um, and then we sub in we do the definite part of it, which is between 5 and x. Now we have this really simple rule, which is 1 minus 5x. Okay. Now if we sub in, oh, what's the probability that x is less than 5? We would just sub in 5 here, and look at that. 1 minus 5 and 5 equals 0. So and that makes sense, right? Because x is greater or equal to 5, it's 0 elsewhere. So you can see it checks out already. B, find the probability that x is less or equal to 8. We're going to sub in, remember that the less or equal to, so the equal part doesn't matter, could just be less than. And that's because it's a continuous type deal. We don't really care about when it's smack bang on, because it's never going to be smack bang on. Okay. Sub it into the formula. So all we do is now sub in 8. And as you can see, yes, we could have done it with a PDF, but it would have just been a bit longer and been a bit harder. And there we go, 0.375. Part C is between 9 and 12. To be honest, I would just use the PDF at this point, because they didn't say use the CDF, but I mean, you can do it. It is doable. You essentially find the probability that x is less than 9, and you subtract that from the probability that x is less than 12. But I would just use the PDF and find um, the interval. So I would just integrate between 9 and 12. To be honest, I wouldn't bother with any of this. This is a bit too, like, I look at that and I kind of feel a bit confused. So I would just use the PDF. You're not going to get marked down for it. If you like, on last year's paper, there was a question 16 on paper 2 was like a specialist question straight up, and I got full marks on that. Or I assume I did, and I just used specialist. It was just a cheeky use sub. So they're not going to penalize you if you get the right answer and you show some level of working out. All right, moving on to our final topic, and that is normal probability. Normal probability, I should have just labeled that at the bottom, but this is the more like, it's the extension of probability. So we've done the introductory, like binomial, continuous, PDFs. We're now going to talk about normal probability, which is potentially the most applicable, because we see this appearing in nature and appearing in real life a lot of the time. Okay, so normal distribution, we're not going to really have much of a discussion at the end of this. If we have time, we will, but I've still got a few slides to go through. Normal distribution. So a general equation is not normal. Well, I don't know. These are both normal, but it's kind of like, what scale do you go on? I will note that these formulas you don't need to know. That being said, if you see anything weird with like a square root of 2 pi and an e to the power of -12, as you can see in both of these, I would probably, like, that's good fodder for a multi-choice question, where they can do, like, it's not every student would have learnt it, so they can test the ones who have nice breadth of understanding, right? So just for me, all I want you to know from here is that the formulas that actually describe this equation, that describes the normal distribution, they've got an e in it, they've got a negative half up there, and they've got this weird square root 2 on pi. That's pretty iconic, like you will remember that. And then we've got two types. We've got the standard normal distribution, which is centered on a mean of 0 with a standard deviation of 1. And then we've got a general one where it's like centered on 100. That actually looks like the IQ one, to be honest. But your calculators are going to do all of this for you. And there's only 3 real numbers that you're going to have to memorize anyway. So it realistically has low tech free capability for questions that they can throw at you. It's more likely going to be in that tech active paper, or you're just going to have to use those 3 numbers that I mean you have memorized. If not, when I went through and I did the April lecture, I did like go, okay, I want this to be comprehensive, and I put it. I'm pretty sure it was April, but I put in absolutely. Maybe it wasn't April. Maybe it was July. Maybe in July. I'm now thinking it's July. I don't know if I did the April one. I don't think I did the April one. It's July. Look at the July one. But I made sure I was like, okay, what did you need to know for probability? You definitely had to know those 3 numbers. So it was the like 68, 95, 99.7% rule, and what Z values to sub in for those. You did have to memorize them. All right. So for a normally distributed variable x, the probability that x is less or equal to a equals the probability that the z score is less or equal to a minus the mean divided by the standard deviation, where z is the standard normal variable. So z is just like how many standard deviations left and right of the mean is it? Okay, so a z score of 1 means that it's 1 standard deviation right of the mean. So in normally distributed data sets, we can say that 68% of values lie within 1 standard deviation, so the middle 68. 95% of variables values lie within 2 standard deviations, so 95%, and then 99.7% lie within 3 standard deviations of the mean. That's the 68, 95, 99.7% rule. Um, and then I'm not sure, I can't remember whether we do go over them today, but the Z you do need to look up the Z values for them. Just refer back to the July lecture for those. I don't want to say it's slightly wrong and for you to write it down. I can ballpark it, but I don't want to say wrong, if that makes sense. Okay, so this is a formula you also have to memorize. Basically, we can work out Z scores, which are really useful, by subbing in X's and the standard deviation. So we can use standardized values to determine how many standard deviations away from the mean a particular value is. They're acquired using this formula. So a positive Z value um, indicates that the value is above the mean, whereas a negative Z value would mean that it's below the mean. We can also use norm CDF and PDF if you're using the T-Inspire non-CAS, or alternatively if you're Casio. Essentially what you do is you just sub in upper and lower bounds, and hey presto, it tells you the probability. Otherwise, if you ever get a question in Tech Free exam, um, on normal probability, it's probably going to be one of those scenarios where you draw it on the graph, and it's going to be some variation of the 68, 95, 99.7. Essentially, what you're going to do is you're just going to work out like the subtle differences. Um, you know, for example, you got to work out what to include. It's not always going to be, if it's 99, you use that rule as your landmarks, and then you go, well, if I'm looking for this point over here, we have to add up the 0.34 here, the 0.15, etc., etc. Okay, so we can use a graphics calculator to find normal probabilities. Okay, um, you can also determine percentiles from a normal distribution. I honestly would have used nsolve here. I did not know you could do that. Oh no, no, yeah, I have used inverse norm before. I lied. These are like kind of like the Z scores, I suppose. Um, Make sure you know how to do this for your calculator. So norm probability, here's an example. So in a year 12 math class, the percentage score of students in an exam is normally distributed with a mean of 73 and a standard deviation of 6. A, find the probability that a student picked at random received less than 68. Find the probability that a student picked at random scored less than 70. Now we just work out how close it is to that mean, and then we extrapolate from the standard deviation. Because they're not nice numbers, this is a tech active question, by the way. You have 3 minutes, have a go, pause the video. Here is the answer. Essentially, we use CDF to find between the interval, sub in the mean and the standard deviation, and we just use norm CDF for T-inspire. These are the different steps for the T-inspire. I have to go a bit quickly now, but if you have any more questions, make sure you let me know in the chat. So basically what this means, having done the norm CDF, we've tabbed through all that, 0.2023 means that there's a 20.23% chance that it's less than 68, and we defined those upper and lower bounds, didn't we? B, find the probability that a student picked at random scored less than 70%, given it is known they scored less than 80%. So this is a bit of a harder example, just because we have to use our conditional probability formula, but the requisite parts are all very doable, so don't be too worried about that. Just sub it into the formula and work it out bit by bit. And there we go, 0.35, which is 35%. Right. In a factory which produces steel beams, the accepted limits for a particular batch of beams is 12.445 meters and 12.445 meters. That's not right. Let me just quickly check what they're actually talking about. Oh no, sorry. I am just absolutely bugging at this point. That's a 4 and that's a 5. So these are two different numbers. Yeah. Just sub in what you know. Have a go at this one. This is a complex familiar example, a classic question. So I would expect that you would have a good understanding of how to tackle a question like this. So assuming the mean lengths are normally distributed, find the mean and standard deviation of the distribution. Take 10 minutes because it is a bit of a harder example. Okay, pause the video, have a go. This is the answer here. So we like to really step out what we know and what we don't know. So acceptable is between that and that. Essentially undersized. So basically the probability that it's less than this is 0.04 and the probability that it's more than that is 0.04. Because normal distributions are symmetrical, we can actually add these two guys and average them to find the mean. Because the acceptable range is going to be like either side evenly to the mean. So we can meet them in the middle. We then use our Z rule, importantly, because now we have to actually find, because if we read the question again, what are we finding? Mean and standard deviation. So classically with all of these questions, we have to use Z scores, which is really annoying. But that's because of how useful this formula here is, okay? And this formula is not given to you, which is why this would be a complex familiar, complex unfamiliar example, okay? So first you have to fill out, what we know, what we don't know. Okay, the probability it's less than that, 0.04, probability it's more than that. Also 0.04, and then we step it out with this formula, okay? Oh yeah, and then using our standard rules, so there's kind of this underlying logic that you'll see again and again. It's like, well, we need it to be less than, for some, to use our inverse norm formula. That's right, I remember that now. So we just swap it. Now we can't just swap z so it's less than this. What we have to do is we actually have to minus 0.04 from 1 as well to give us 0.96, which is what you can see here. Now what we can do is we use inverse norm. We find the z value, which is then going to help us is going to let us set up two simultaneous equations. As you can see going down here, we've got two simultaneous equations. Remember, there's a divide by the standard deviation here. Set up equals 1 equals 2. Flip them over. You could do substitution. I'd probably do elimination just because you could flip 1 multiply them 1 times 2, and it's going to eliminate them nicely. No, that's the inverse norm function on the t-inspire, and then these are the requisite steps. So we can then sub the mean equals 12.45 into one of the equations and solve for the standard deviation. So sub it in. Now that we've eliminated that, so that's what they did down there. They solve for this. We can now also find the standard deviation. Okay. Oh wait, well you could use. So what I was saying was the generic strategy, where it's like, but since we know the mean, we can actually just straight away sub it in, which means it's actually not that bad. This might even be just simple familiar, because otherwise, we'd have to solve for both variables, and then at that point, you can imagine that the difficulty is certainly rising at that point. But then we just sub it in. Too sweet. All right. So it's possible to use the normal distribution to approximate the binomial distribution. Recall that the shape of a binomial distribution depends on the number and the probability. So when n is large enough and p is not like either 0 or 1, we can actually approximate that it's normal. Now there are two rules, and that is that n times p is greater than 1, and that 1 times 1 take p is greater than 5. Now, these are pretty sucky rules. Basically, you're just going to have to memorize them. Who knows, you might be asked a question where they're like, oh, well, is it normal? You would had to have memorized this formula to then be able to spit it out and go, oh, yeah, it's normal because it fits those rules. Okay, so just memorize those two, np greater than 5, and then 1 times 1 take p is greater than 5 as well. Specialist does a couple of more. When you approximate a binomial distribution using the normal distribution, we get the mean and standard deviation this way, um, because this is just the EX formula, so the expected value. These are just on the formula sheet. And then the standard deviation is the square root of the variance. This is the variance. So nothing too crazy here. Don't bother writing that down. And then we deal with that with any normal distribution. So, it is known that 30% of residents in a Brisbane electorate approve of the current local member. If 1,000 people were picked at random, approximate the probability that between 270 and 330 people approve of the local member. So, first we have to do a bit of a Bernoulli, and go, okay, let X be the number of people who approve being success, failure being not approve. We're assuming it's binomial, so it's Bernoulli trials, Bernoulli repeated trials, n equals 1,000, probability equals 0.3. And then we're going to use the normal to then solve for this next part. So pause the video, take 5 minutes, see if you can work it out. No problem if you can't. We're going to briefly go through it right now. So we can work out the mean. The mean is 300. That's also just halfway between 270 and 330. So once again, it checks out. Now we can work out the probability that's between 270 and 330 using our z-scores, okay? So we can actually just nicely swap in a z instead of an x here, right? But to do that, we can't just leave it as, we can't just swap it into here. We actually have to convert this to a z-score. So we have to do the weird x minus the mean divided by the standard deviation. But fortunately, we've already worked out all of those. So we can just sub them in, work that into our calculator, and actually work it out. This is a really nicely worked answer because it just transitions cleanly from x's, which we know that's the question, to z's, and the z, as we can see, is the more useful number, given that we know the x and that we know the standard deviation. Alternatively, we could also use our calculator. And this is the physical representation of the interval that we are looking at. All right. Well, that is actually doing us, and yeah, I honestly thought I had a couple more slides. But thank you for watching. Good luck with the rest of your studies. You are approaching the end of your study, and it's honestly very tough. You obviously have other subjects as well, and you're obviously very stressed. Like for me, I'm thinking, how on earth am I going to get into medicine? It's obviously super competitive. Like for my course, there were 40 spots available, and there's like 3,300 people who apply. Those are the kind of stats that you hear, and you're like, oh my gosh, how on earth am I going to get in? Hopefully, some of you have already got a planned pathway, or are fairly confident, but all you can do is give it your best crack. And sometimes stuff won't go to plan, and that's fine because there's always another pathway and another way to get in. Make sure you prioritize yourself. I don't mean like don't study. I mean get the stuff you want to done. But if you don't get 10 practice exams done in a day, don't be too upset because everyone is human after all. And you really can't talk down to yourself during this period. You are in holidays, which means you are in the prime time for study. So for methods specifically, it's all about doing volume of exams. I do actually genuinely recommend getting the 8 Plus portal, because what you do is you just start with the topic tests because those are probably like they can be a little bit off syllabus sometimes, or like the marks just won't quite marry up. But I honestly found the methods one to be a really nice kind of like gauge of where you're at. Do that first, then do the neat practice exams, do textbook tests, I suppose. But then again, if you've gone over the textbook in some detail previously, don't be too worried about that. Finally, do your past papers, and make sure you set your past papers in exam conditions because you want to kind of see where you're at. So I got 48 out of 50 for my methods external, which kind of translates to 96%. That being said, on all the past papers, I was only scoring low 90s at best. You don't do as well on even the past papers you sit in exam conditions, and that's because, well, when you mark it, you're probably going to be a little bit tough. But also, you're going to reach peak performance a bit later on. Okay. So yeah, be really kind with yourself, and make sure you have a nice breadth of understanding. It's not about doing every single variant of question, because guess what? QCEE is going to find one that you've never even thought of before. That is kind of just how it works, unfortunately. It's more important that you develop your exam skills and develop the ability to be able to work out stuff, which sounds a bit voodoo, but essentially you need to have the ability to, when you're sitting in the exam, you don't panic because a lot of people hit the panic button emotionally. They're like, oh no, I don't know, I'm stuffed. Oh, I'm going to fail this exam, and you get that. Even the best of us, like chemistry external, for example. No, methods. And the last question was that really weird log question. To date, have not met anyone else who's correctly solved that question. You had to like prove one thing equaled the other. Now, I went through that, got it wrong, didn't work, trapped. Went through, did the rest of the paper, came back. Then I got it right. You had to do this like weird substituting the base thing, and it was the second go where I got it. And even chem, like there was a oxidation of alcohols question where I just didn't get it. And then I got it at the end. You have the eureka moment where you realize, because you've got to give yourself your brain time. That's why I actually recommend, and this is a bit controversial. I remain the only one I've heard who've tried this, but basically, when you have your perusal right, it's not, it's pretty useless looking. Like, don't even bother looking at the multi-choice questions. You can guess them if needs came, and it's worth nothing. Like, of course, you have to do them, but your brain can be pretty dead and tired at that point when you do them. You know what point your brain can't be dead and tired at? When you reach question, 20, 21, and it's like, this super hard question, and you can't, your brain is exhausted by that point. Physically, it is. It's, for all intents here, like a muscle, okay? Metabolizes like a muscle, in fact. Um, so what I actually did is in perusal, didn't bother with the easy ones. Like I'd flick over them, not the multi-choice, but I'd flick over and be like, okay, that's binomial, and you just identify the probability type, or that's optimization. Yeah, duh. Like I'm not gonna try and think through all that. Like I can kind of vibe out what topic that is. Yeah, that's a win for me. Keep going, and then you move on to the last question. I spent probably all of the 15 minutes perusal, or 10 minutes, just like staring at that last question, trying to work out what the heck I was going to do. I couldn't figure it all out. Because basically what that means is you're staring on that last question, trying to work it out. And then they say, oh, you know, you can pick up your pens now and start writing. And you can grab your pen and you start on that last question. And honestly, I never would get the last question right straight away. And that's fine because I'm human, everyone's human. But I would get, I would have at least gotten half those marks in part marks. And then I just missed the, like, change of the base step. Crap, I don't know what I'm doing. Go back, finish the rest of the paper, come back with those 20 minutes, rub it out, rub out the, the scribbles that I'd done till my last like valid line of working, and then fix it up from there. That's honestly what I recommend. Is to do the last question first, and I did that for specialists. You know, I got 92% for spec because went back to front. I couldn't finish a paper in the time just because those last three questions are ridiculous, and methods is similar, right? So you want to get those questions done and then gain momentum on the back end instead of like reaching, doing the hardest thing when at your most tight. That's my perspective. You've got lots of time to still do these practice exams, so try one of them where you actually flip the order. Anyway, good luck with your studies. Good luck with your pathways, and good luck with life. Make sure you reach out if you have any questions or you want any tutoring or anything like that. All right. Thank you.